Hi guys, welcome back to another webinar of ours. I hope people in Mumbai are keeping safe, while here in Pune things are much better, and I hope they get better for Mumbai soon too. Yeah, guys, take care, everyone over there. Today in our webinar, we are going to discuss algebra. We're going to discuss, more tricky applications of quadratic and whatever other equations as well. A little bit of absolute values, the application of absolute values as well. Basically, the kind of questions which are at 705, 805 level in GMAT, where you do need to know quite a few different concepts of algebra. Yeah? So as we go through the questions, we'll discuss on which important points you should keep in mind. You know, what is it that when you look at that, it should remind you of this, etc. Right? So I'll share my screen with you and we'll start with the first question. So those of you who are joining for the first time, I'll tell you how we run the webinar. I'll share my screen. I'll share a question with you. I'll give you a couple of minutes to try out the question on your own. Once you're done, then we'll do the question together. And then I'll give you half a minute or whatever to ask your doubts if you have any on the question, on the explanation, whatever. Yeah. All right. So let me share my screen with you. So if x square minus ax plus b equal to 0, so we have a quadratic over here, yeah? In the quadratic, I know that I can write a quadratic as x square minus sum x of the roots plus product of the roots, right, equal to 0. Perfect. So essentially, my a over here is sum of the roots, and I'm given that means that sum of the roots is less than 9. And I'm asked about the distinct possible values of B, which is the product, right? So I'm asked about product. All right. So sum should be less than 9. The roots of the quadratic are positive integers. So essentially the roots will be like 1, 2, 3, 4, etc. Right? Okay. And their sum has to be less than 9. Think about it. So basically my, let's not call it X, let's call it M. Yeah. So M plus N has to be less than 9. Let's say the roots are M and N. So then I can say that M plus N are less than equal to 8, right? Because they are positive integers, their sum has to be an integer, positive integer as well. So less than equal to 8, yeah? All right, excuse me. So basically the roots could be like, let's say 1 and 1 or 1 and 2 or 1 and 3 or whatever, something till, let's say 1 and 7 or for that matter 4 and 4, etc., right? So now tell me one thing. What is the maximum possible product? How am I going to, evaluate this? I need the possible values of the product. So I know a lot of different products are possible, right? But then there could be double counting as well, right? I can't just count in how many ways can I choose an M and how many ways can I select an N and then multiply that, because the same product could appear in two calculations, right? So that is not the way to go about it. All right, so then let's do it the other way around. Since I need the number of distinct possible products, so I say, all right, so then how many products are possible? I know my product can be 1 or 2 or 3, etc. Let's say if the roots are 1 and 1, the roots are, let's say, 2 and 1, the roots are 3 and 1, etc., right? What is the maximum possible value of the product? Since the maximum possible sum of M and N, this is equal to 8. The maximum, I have to remember, and this is very important, that if my sum is, let's say, 8, then the maximum product will happen when both M and N are equal, right? In fact, this is the point of transition, that this, the variables are equal is a point of transition. So that is why we should, check whenever something like this happens, we should check what happens when both M and N are equal. Yeah, it's a rule of thumb. It helps us arrive at the answer in many cases. Okay, so then my product is going to be maximum when M is equal to N. Of course, that means that each is going to be equal to 4. So my product is going to be maximum of 16. Right? And this happens, of course, when my roots are, for example, 4 and 4, fine. Yeah. Now, all I want to see is, can I have all these as my product? I know I can have 1, 2, 3, etc. Can I have all the numbers between 1 to 16 as the product? I know the maximum product is 16, right? All right, 15, yes, 5 and 3. Yeah, the sum has to be less than equal to 8, happens. Okay, 14, 7 and 2, right? If I want the product to be 14, the roots have to be 7 and 2. right? Or 1 and 14, anyway, 14 cannot be one of the roots. But even 7 plus 2 gives me a 9, right? Not an 8. It's more than 8, which means 14 is not acceptable. Then I have a 13, of course, 1 and 13 not acceptable. 12 is fine, 4 and 3, 11. Basically, focus a little more on the prime numbers. I'll very easily be able to find for most of the composite numbers 2 small roots, right? 11, 1 and 11, again, not possible. 11 cannot be a root because the sum of the roots has to be less than or equal to 8, right? 10 works because it is 2 and 5, the sum is 7. 9 works because it's 3 and 3. 8 works. Then from 7 to 1, of course, works because the roots can be 1 and 7 also, right? 1 and 6, roots can be 1 and 5. And so, of course, I don't even have to check for those. So essentially, there are 3 products which are not possible: my 11, my 13, and my 14. So out of the total of 16, I have to subtract 3, and that is how I get 13. Is this okay?